Hello, welcome to our seminar Microservice Architecture with AWS Services, presented by Svitla Systems. I'm Illya Reznikov. I'm Senior Cloud Architect and Europe Lead of Cloud Practice at Svitla Systems. My co-speaker today is Thibault Philippe. Thibault?
Thank you, Illya. My name is Thibault Philippe. I'm Director of Cloud Services, Svitla Systems, Lead Solution Architect at Svitla Systems as well. We're happy to have this webinar with you all today, and we look forward to talking to you about microservices. Next slide, please. And quickly, I'll discuss about Svitla Systems. Svitla Systems has been around for almost 20 years. We have over 1,000 engineers, 10 global locations. We have pretty much done projects in literally every space. And, we've worked with startups to Fortune 500, and a lot of our clients have been with us for over 2 years. So we have been around, we're growing, and we are here to stay. Next slide. Svitla Systems is what is called an advanced tier partner of AWS. What does that mean to clients? That means AWS has recognized that Svitla Systems has a large number of certified professionals working for them. And there's a certain number that you have to be this advanced tier. In addition to having certified, qualified individuals, we have completed numerous projects that have been certified by AWS, that they recognize what we've done for our clients, and there's a certain number of projects that you have to achieve in order to get an advanced tiers, in addition to having certified professionals like Illya, who can talk at high levels and very granular detail levels. And finally, when there are a numerous sets of clients who have given testimonials on behalf of Svitla Systems for us, and these are testimonials that clients have given to AWS. We are certainly willing to share that with anyone here who's looking for partners. So having not only is Svitla an advanced tier partner, that means something, and that we're going to bring things to the table. In addition, we can also, if you're on AWS, we can work on your bill and make it lower. And if you're not in AWS, we can help migrate you to it, because we have a lot of certified experts in it. Next slide. And with that, I'll turn it back over to Illya.
Thank you, Thibault. So key points of today's seminar. Well, obviously, we will speak about microservices architecture, and we'll discuss how microservice architecture could be tuned to business needs, why it's so important today, how to build microservices architecture applications. We'll review and discuss how AWS services could be used to implement microservices, benefits which it gives us, point to some services that could be helpful in this for design and implement such applications. Also, we'll take a look at real-life Svitla case studies, where from startup to enterprise, where we implemented microservice architecture applications, and we'll discuss which benefits they give for our clients. So let's start with definition. What is microservice architecture? Based on definition from microservices.io site, microservices is an architectural style that structures an application as a collection of services that are independently deployable, loosely coupled, organized around business capabilities, and owned by a small team. This is technical side of definition, but why it's useful for organization, why it's important. It's important because microservice architecture enables an organization to deliver large complex applications rapidly, frequently, reliably, and sustainably. It is its necessity for competing and winning in today's world. So Microservice architecture should be used in those cases when it gives these benefits to your businesses. And let me start with first poll. That is, how familiar are you with microservices architecture? I guess you see a questionnaire, and let me continue. Good. So let us speak about why microservices architecture is important for business. As we said, microservices are like small application parts organized around business capabilities. On the one hand, it definitely requires more time and efforts to implement because it requires to review business processes. It requires to tune architecture to your business processes. Probably it's even required rework of some processes if it looks like they are not efficient. They will not be efficient in new architecture. Probably in most cases, it requires to hire expert professionals who may do this work for your company. But when microservice application is designed and implemented, it gives a lot of benefit for business. It improves business agility. It allows to, it should be scalable. It allows to faster time to market. It improves user experience. On the other hand, because each microservice could be like carried as a separate part, it improved IT efficiency because in this case, microservices could be developed independently, that could be quickly and easily, and it obviously reduces the workload on IT staff and free up their time for more strategic projects. As a result, it enables an organization to respond quickly to changing market conditions and customer needs and business requirements that help businesses to improve their competitiveness, deliver better products and services, and drive growth and profitability. Also, as we mentioned, microservices could be optimized for specific use cases, and that is why it allows to improve user experience. But where is cloud services? We spoke about microservice architecture, and I guess you all know that cloud services has been intensively developed in the recent years. But as well, business representatives, you should know that each new tools or new techniques should be like applied to application, to development process only in that case if it like works. So there are no silver bullets, and in this case we need to ask a question: is it worth to be applied or not? So why we are speaking about microservices and AWS cloud services? Let me provide answer a little later, but let us first take a look at benefits of cloud services. Cloud services gives a lot of benefits. Idea that cloud services are services provided by cloud provider, such as AWS, GCP, Azure, some others. Main idea of cloud services that cloud provider cares about infrastructure, about security of that infrastructure, about reliability of that infrastructure. And cloud services could be deployed in different models like infrastructure as a service, platform as a service, software as a service. It could be serverless. And based on particular service and particular deployment model, cloud provider could do more task to manage the service or a little less. So in total, it gives us as a consumer of this cloud services, improves security, reliability, high availability, elasticity, agility, and scalability, and others. But well, it sounds a little similar to what we already said about microservices. And in that way, I would like to say that microservices and microservice architecture and cloud services are a perfect couple. And microservice architecture is particularly well suited to cloud services because it allows for easy creation and deployment of small independent services that can be scaled and managed independently. By using cloud services, organization can focus on development and delivering high quality services rather than managing infrastructure. Obviously, it gives a lot of profits as resource optimization, as cost optimization, and what already mentioned, improve IT efficiency. Cloud services provide many benefits that make it easier to build and deploy application using microservices architecture as reusability of code, and we'll take a look later how it could be implemented. It allows to implement various approaches to design as domain-driven design. It allows to implement best practices like, for example, design for failure or provide automation of these microservices. And later let me switch to first case study. Thibault, you're muted. Thibault.
Sorry about that. I'll quickly go over a series of case studies in this presentation, but I want to come back to the first thing that Illya said. There is a business driver for microservices. There's always a business driver for microservices. Customers, clients, and users, they want more features. It's a much tougher market. You have to keep up with what your client needs are, and you have to be responsive to your clients. Otherwise, they will find other places to do business. And if your IT does not support the business in that regard, it's going to be a problem. So we're going to give a series of case studies throughout this talk, and various different industries, various different types of businesses. And the first one is a startup with a very limited budget. Now, at Svitla, we work with all sorts of clients. We've worked 20 years in this, company started in the Bay Area, a lot of startups out of the Bay Area, startups with limited budgets. So they were looking to build an MVP, basically with some, what they call modern UI technologies to make it look good and pop. So we came up with two proposals. One, the traditional service-oriented architecture, or to do it in microservices architecture. Now, given the timeline of they needed to do an MVP right away, it was decided to do the traditional architecture, but make it in such a way that it would be easily re-architected later on. Now, you may find yourself in that kind of situation. So again, it's about what fits the business need. So typically when IT does things, it has to meet the business need. It has to meet the business driver. Next slide, please, Illya. Obviously, the first proposal initially was a basic traditional service-oriented architecture, 3-tier, obviously large single database, available for horizontal scaling. This architecture was available, reliable, secure, and it met the need of the client right away to get the MVP out right away, validate the business model, get funding. It works. And I'm not saying that service-oriented architecture, traditional 3-tier architectures don't work. They do. It just depends on your business needs. Illya, next slide, please. Thank you. Now, as you see, after the MVP and the original and the second proposal, we build out their true microservices architecture. Now, why do you want to go to this microservices architecture? Number one, each individual service is separated from each other. You can build it out into different teams, different individuals, and not worry about collisions. It's much easier to test. And more importantly, it allows for fast deployments, various changes in and out, which is very important for a startup because you're a lot of times you're testing the market, you're testing to see what works, and you need to make changes right away. And being in a microservices architecture allows for that. So there are a variety of things that you need to think about when you're, especially if you're a startup and you're making your initial decisions. Hey, when's your funding coming up? When do you need to have an MVP ready? How's it going? And those are the things that Svitla can help you with. Illya, turn it back over to you.
Thank you, Thibault. Thank you for answering the first poll. So let me share with you a second poll. What is your organization current software architecture? And while you're answering, let me speak about AWS. So why we are using AWS cloud services in our work, why we implemented our application for our customers using these services. So in short, I would like to say that AWS currently is the leading cloud provider. So it has significantly more services and more features within those services than any other cloud provider. It allows to achieve faster pace of innovation. It in working with application for our customers, we could rely on unmatched experience in maturity, reliability, security, and performance of cloud services. In case of proper using cloud services are cost effective because in general, customers pay only for computer power, storage, and other resources they use. Also, Svitla as advanced tier partner could provide some benefits for our clients when they use AWS cloud services. AWS cloud services are could provide security which could be used to harden our infrastructure, including all layers, including physical, operational, and software measures. And also, AWS has the latest global infrastructure footprint of any provider, and this footprint is constantly increasing at a significant rate. For customers, it means that they able to put cloud resources exactly in that place where the most users are located, and it means that it gives the lowest latency, it gives the better user experience, and in overall it improve reputation of particular business applications. Okay, let me come back to you, Thibault, with case study number 2.
Thanks, Illya. The second case study is a sort of like a mid-sized to larger enterprise client. They had a application already in the work. It had been working for a long time, but they were looking for improved performance and improved scalability and availability of their application. So they came to us to help them move to a microservices architecture. Now, Svitla Systems has a lot of experience. We have a lot of certified professionals like Illya who can help you through that journey. We can also work with other partners as well to, help you move along to where you need to be. And again, why did this client need to move? They needed better insight. They needed to serve their customers faster. The business demanded the change out of the IT team, which is really important because obviously if the clients are not satisfied and your end client businesses, your business's end clients are not satisfied, you will not continue to have their business. So like that end client is expecting 100% availability, 3 a.m. in the morning. If your website is there, it's got to work. Scalability, performance, it's got to be fast. You need to have basically updated technology stack. You need to be able to extend your architecture. You need to extend your infrastructure as you need to, which we did with this client. And there's going to be some talks, design specific principles that Illya will talk about further in the talk that will give that as a design principle. So again, I'm going to harp on the same thing. Business drivers drive the need for microservices. Illya? Oh, sorry. So once more, again, this client had a traditional three-tier architecture. It was low performance, outdated UI, and they were losing clients basically because it's a monolith. And the one thing with a monolith that unless you're in those kind of legacy environments that you have to understand is testing is very difficult. You have to test the entire application. You change one line of code, you need to make sure the whole thing works because you're deploying it as is. So if you don't have a very solid testing methodology, if you don't have automated test cases, you don't really know how great any fix is going to handle when you move to production. So like traditional three-tier service-oriented architectures implies an extensive testing procedure. You may or may not have the business drivers to facilitate that. Illya, next slide. Obviously, we moved them into a microservice architecture, allowed for a migration process to do that. It's very easy to horizontally scale, so you can extend your infrastructure as you need to. Now, this application is much more highly performant. It's much more reliable. Testing is now much easier because now, since things are deployed as microservices, you can test individual components at a much faster rate and deploy it more confidently and roll it back easily if there's a problem that you don't find in testing. And that's a key point, right, that microservices give you. How do you get this agility? You get the agility by testing. You don't have to test the entire application. You can test the pieces that are necessary. And that business agility is what you're driving for. Illya, back to you.
Thank you, Thibault. So based on examples which Thibault described us, we see that there are no black and white solutions. Each solution could be, each architecture proposition could be designed according to business needs, according to business restrictions. And we in Svitla trying to use right tool for the right job. So it means that we use particular service and particular tools, a tool exactly where it should fit its needs and where it gives, well, our customers the better, the most efficient result. According to architecture, which based on examples which we described right now, service-oriented architecture could be good for small project or simple applications. It could be good for well-documented, slow-changing businesses. It could be good for organization where some business requirement requires a centralized governance and control over services. On the other hand, microservices applications are good for complex business-focused application. As we already said, microservices should be designed to be around business capabilities. It should be tuned with business processes. Microservice architecture is a good fit for modern cloud-native applications because a lot of microservices could be like deployed as just one to several cloud resources. Using these two approaches, our customers get better scalability, agility, resilience, and performance of their applications. And also because microservices are in some sense independent parts, it allows to implement projects with technology heterogeneity. So let me switch to the next poll question. And how important is it for your organization to adopt microservices architecture next year? Thank you for answering. And in second part, in second part of our seminar, we'd like to speak about design principle and best practices which we are using in our work for microservice architecture. So among them, we'd like to pay attention to loosely coupling principle, how automation should be used, speak about security best practice, about monitoring, about horizontal scaling, load balancing, and speak about distributed data sources that could be used to enable each microservice to have its own data store. And we'll speak about containerization, where we are able to package microservices and their dependencies into container and use them as independent parts. And obviously, we'll speak that serverless architecture and serverless cloud services should be used whenever it's possible. First principle is loosely coupling. Obviously, I saw from answers, loosely coupling is a key characteristics of microservice architecture. When it's implemented, so its idea of this principle is that parts should be independently work each from others. It could be achieved in different ways, so it should be achieved by architectural point, and also it could be achieved by implement and deploy microservices using cloud services, for example, which could provide message-based communication. In that case, for example, we could use Amazon Simple Queue service or Amazon Simple Notification service. When microservices work independently, it allows to efficiently use resources and provide additional scalability, because each particular service could be tuned independently without affecting the entire system. In the same way, it allows customers to have better team organizations because when each team work on one or several microservices, it means that these teams could use their own technology stack. And for example, AWS Lambda support different programming languages like .NET, Python, Go, Ruby. And another very interesting benefits which could be achieved by implemented loosely coupling principle, that it allows experiment and innovate faster. Once again, because each microservice is independent from others, it means that, and using cloud services, developers are able to try some new service, check does it fit to their needs, and then if it fits, okay. If not, we could just switch to another one and do it quickly without like affect the entire system and broke everything. Next principle is automation. We'd like to say that automation should be used whenever it's possible. Because using automated automation, at first we get consistent deployment to run the same process each time. It improves quality of product, it decrease manual intervention, and obviously it save time of our developers and DevOps engineers on do some manual works. It allows to faster deployment microservices to market. It allows, well, I'd like actually automation of automation, and if DevOps processes are designed automated in correct way, it's possible to reuse them. So in this case, we are able to reuse deployment processes. Also, automation, well, provide predictable view of what is going on. So it's improved visibility into deployment process. AWS provide a lot of services which could be used to automate processes. On the one hand, there are a lot of developer tools like code build, code deploy, code commit, even integrated development environment, Cloud9. On the other hand, it's infrastructure as a code tools like CloudFormation and the Cloud Development Kit. Also, we already mentioned about ability to use different programming languages. Cloud Development Kit allows to use different programming languages to model application. Next very important principle is security. Security, well, should be applied everywhere. So on the one hand, Amazon provides a tool which is called Amazon AWS Identity and Access Management, which allows to set up fine-grained access control, where it defined who, users or role, has access to which resource. To authenticate users, we could use directory service or Amazon Cognito based on our requirements. Using Amazon Key Management Service, we could encrypt data at rest, at transit, and it means that our microservices became more secure. We could add some security checks, automate the security checks, and achieve built-in compliance. Using Amazon Virtual Private Cloud, Amazon VPN, Direct Connect, and other network services, we could implement security networking. Also, it allows to separate microservices from each to other, and it improve security of each particular service. So if in one microservice security will be broken, it means that other services will be alive, and it decrease reduced risk of data breaches. We already also we could mention some other security services, like for example AWS web application firewall, which could be used to protect web application from web exploit and bots, guard duty, inspector, and a lot of others. So let me invite Tibut to provide case study.
Thank you, Ilya, again. This third case study is a very special case study for both Ilya and I. We've worked with this client at a high level before. This client is a large water products company in the United States. They are rapidly growing, work with city utilities, work with other corporations, and they're going through a massive restructuring, and they're acquiring a lot of companies. They had a legacy monolithic application. They went to AWS and started working on an architectural procedure with them to get to help drive their progression into microservices. And you can see the list of services that were being used. Now, in terms of their work and how they worked with Svitla, like I said, they went with AWS to work with to set the architectural guidelines, and then they came back to Svitla Systems to provide the resources to help drive those changes. So at Svitla, we can work as your thought leader, as your architectural guide, or we can work as the hands and feet to help guide your transition into microservices. And this work is still ongoing. Obviously, it's a huge monolith. It's been going on for 2 years. They've radically changed how their applications work. And as you note, it's still using .NET. So you can continue to use .NET Core legacy technologies, but migrate to microservices. So you don't have to, there's a saying, throwing the baby out with the bathwater. You don't have to do that completely when you migrate to microservices. And, we can help you both ways, as a thought leader or as your hands and feet. So thank you, Ilya. Now back to you.
Thank you. Another principle which we use developing application for our customers, it's monitoring and logging. Well, the goal of monitoring is collect logs and analyze them. Analyzing logs, as probably the most important thing, we could proactively detect issues before they cause major problems. AWS provides such, I guess, well-known tool, well-known service that is AWS CloudWatch, and it's able to collect logs. It's able to set up alarms. Actually, it's separate service which is called AWS CloudWatch Alarms, and it's able to like raise alarm if well, something goes wrong. We may use logs and services to monitor performance and as a result improve reliability. We will be notified if for example resources are overutilized or underutilized, and some of these cases could be well managed automatically. For example, add more resources or decrease resources if they are not used, or it could be notified some like live person administrator to do something. Using monitoring, we definitely enhance security by identifying security threats and vulnerabilities. For example, AWS provide special service that is called AWS CloudTrail that could monitor API calls to microservices and out microservices. Using monitoring, we will know more about our application, and it allows to better to make a decision better than without such information about system. Also, I could mention such tools, such services as, for example, Amazon Management Services for Prometheus, that is Prometheus compatible service that monitor and provide alerts on containerized applications. I could mention AWS X-Ray, very powerful tool that is distributed tracing service that can be used to trace requests through microservices in cloud native applications. Another principle that also should be implemented in any cloud application, especially in microservices application, it's implement horizontal scaling and load balancing. Main idea of this principle that, well, workload are not stable. In major, usually it could has some peaks, or for example at night it has less requests. In this case, using monitoring, we should set up rules that allows to horizontally scale service. And obviously, because we are scaling the services, we need to load balancing, which will spread requests to all instances, not to only one. So using this principle, we definitely could increase scalability of our system, improve performance of our microservices. We'd achieved better resource utilization because all resources which exist right now are used. So it means if they are not used, they will be removed. If there are not enough resources, they will be added. As a result, it gives us cost saving because no unused resources in our application. And well, as a result, it gives better user experience because system became stable, responsible, and has a good performance. As we said, AWS provide a lot of services. In this particular case, there are such services as after scaling, and you see, so actually right now there are 3 different after scaling services, each one designed for particular kind of resources. It's very powerful service that is elastic load balancing that automatically distributed in common application traffic across multiple targets and virtual appliance in one or more availability zones. Based on our needs, we could create network load balancer, application load balancer, gateway, well, classic load balancer. Amazon provides a powerful DNS web service that is called Amazon Route 53. Another approach that we should implement in a microservices application are distributed data sources. Well, one of the principles that microservice should store and manage its own data. it, on the one hand, reduces the need of centralized data management, and also it enables greater scalability and fault tolerance. Distributed data sources could include databases, but it also could include, for example, message queues or object store or file stores. Using different data sources, we are able to have, well, the best possible data model in each particular services. So it allows us to have various data model across different microservices. Using, I would like to say, serverless managed data services, we could achieve multi-region support. We could get additional cost saving. We could have additional development flexibility. So Amazon provides more than 15 purpose-built database services from Aurora, which is relational database service, till DynamoDB and Elasticcache and the other. It provides S3, AWS S3 service that is fully managed object storage, and QoS services, and a lot of others. And let us share with you one more case study.
Thank you, Ilya. Again, another case study here was this was a medical client. They're building a platform. They were initially a small startup, but they grew very rapidly into a mid-sized company. They used a variety of AWS services. They also went through this transformation of basically service-oriented architecture into new microservices architecture. Why did they do that? Because they needed to, one, reduce their operational costs, and two, they needed to increase the reliability, because basically their operational costs were very high due to the large-scale databases that Ilya just talked about, right? Obviously, if you distribute your database, your costs can go down, the same amount of data, but the costs would go down. And they use different methodologies to do that, right? And again, what was the desire to go to microservices? They had a business need. So there's always a business need that forces this. You either have, and almost all of these companies and all these case studies that we're talking about, one or more of these design principles that Ilya is talking about are some of the rationales behind the microservices move, right? From a technical standpoint, right? So what Ilya is talking about is things that all companies are going through that are thinking about these microservices re-architecture. So again, and especially with this client, they grew very rapidly, especially after the microservices re-architecture. So they were able to get their entire system much more stable. They were able to satisfy their customers and be ready for the next phase of, basically growth and basically funding. So again, business drivers, microservice architecture, they go hand in hand. So yeah, back to you.
Thank you, Thibault. Next principle which we'd like to discuss is containerization. So it's idea to use containers as these small deployable parts where we could put code and its dependencies. It gives a lot of benefits across them. We could mention that it will be consistent across different environments because the same image could be deployed to each environment. It's add scalability to meet changing this demand. Well, containers allows to easily be portable. Improve security. It could be integrated with DevOps processes. Well, I would like to say in most native way. And also, as a result, it gives it improve or extend our code cost efficiency because we will work only with what we exactly need. AWS provide a lot of services to work with containers. Among them, AWS Elastic Container Repository, which is a fully managed container image registry. It could be public or private, and even more, it provides additional security features as scanning for vulnerabilities on pushing images. There are Amazon Elastic Kubernetes service that is a managed service that can be used to run Kubernetes on AWS. There is Amazon Elastic Container Service, which is like lightweight Kubernetes on Amazon, on AWS, and some others. Sorry for that. And the last principle is there are serverless, and we encourage our customers and our developers to use serverless services whenever it's possible, because, well, actually, what does it mean, serverless? It means that actually it's service provided as software as a service deployment model, but in addition, cloud provider cares about security, scalability, availability of this service, and some additional features, for example, like cross-region replicas and so on. As a result, our developers engineer could save time on working or caring about management infrastructure. They could concentrate on working with business tasks, working on application code, without, well, needs to care about scalability, which we gain as which we obtain automatically. We could reduce operational cost. We could improve fault tolerance. Well, actually, we reduce complexity because, well, less task, less complex system. And as a result, such kind of services allows to quickly try something, some idea, some approach. If it works, okay, we could continue our investigation. If it doesn't work, we could quickly remove it, just pay for small amount of money for exactly using compute power and try some another services. AWS provide a lot of different services. One probably the most known is AWS Lambda, that's a serverless computer service. It's API gateway, it's Amazon Event Bridge, step functions, Amazon Batch. So whenever task you have, probably you will able to find serverless service which could solve this task and allows developers move quicker and provide better code, better application, well, and benefits for business. Let us share with you one more case study. Thibault?
Thanks again, Ilya. This client is involved into environmental accounting software. Now, this is a highly regulated environment, right? So they needed to go through a major development upgrade, and they brought in Svitla as kind of like a thought leader and implementation partner in order to move to microservices architecture. Not only did we move them to microservices, we helped migrate them to the cloud. So not only does Svitla do microservices, we do cloud migration as well. So wherever you are in this journey, we can help you get to where you need to go. And once again, I note again, they had a lot of legacy code, right? It's .NET, ASP.NET. We were able to help migrate that code into the microservices architecture as needed, right? So it would basically help them bring new companies into their ecosystem much faster. And again, I go back to this point, which I've been harping on the whole time. Obviously, the business drivers. And I don't know if anybody got a chance to see the last webinar we did by our CRO's SVP, Mark DeMeo, talked about the need for digital transformation. Digital transformation means getting more customers, having better products. In order to do that, the best way to do it is be responsive to your customers. You want to do that, you have to make your system flexible enough so you can try things just like Ilya said. See if it works. If it does, scale it out. And then if it doesn't work, get rid of it and put it away. And you can't work in the old waterfall mentality that way. If otherwise you will lose business share. So business drivers, again, help move the needle on microservices. And I hate to be a broken record here, but that is the fundamental thing that is there, right? Business agility, in essence, requires microservices. Ilya, back to you.
Thank you, Thibault. Wow. Let us summarize. Microservice architecture is a power tool, and it gives business a lot of benefits like agility, scalability, reliability, and can lead to faster time to market for new products and services. AWS provides a variety of tools and services for implemented microservices applications. We discussed how using microservice architecture could be joined with AWS services to implement best practices and design principles. We review several real-life use cases from startup to enterprise. And we encourage you to invest in microservice architecture using AWS services. In this case, probably you will need expert or trusted partners as a Svitla Systems. So we are welcome. Thank you for your attention. Probably we have several minutes more for Q&A session. So we have several questions from audience. Okay, the first one, with all the talks of multiple microservices, would there be an increase in operational complexity? Thibault, do you like to answer?
Sure, I would love to answer that question. Yes, initially there is an increase in operational complexity from a traditional 3-tier or a service-oriented architecture. But as your team gets more familiar with how to monitor a microservice architecture, how to deploy microservice architecture, learning how to use IAC, learning how to use all the monitoring and logging tools, this increased complexity will dwindle as time goes by. And you will begin to rely on the increased operational insights that you're getting, right, from what you were seeing as opposed to before. Much like you said, one key factor is the tracing. The tracing will be much easier to figure out where problems are and isolate the problems to the specific microservice. Now, tracing in a legacy style system would be, okay, it's going to hit the monolith and it's in somewhere in the monolith, right? We're going to have to do a code build. We're going to have to test everything, and it's going to take some time. We hope it works. And so as your team gets more advanced with microservices, this operational complexity, while it is there in the beginning, will dwindle as time goes by. And Svitla Systems has numerous certified professionals like Illya that can help you with production monitoring and help train your staff as you transition into this microservices environment.
Thank you. Okay, next question. Are there specific design patterns similar to traditional regular 3-tier architecture? Okay, Thibault, do you like to answer?
Yeah, sure, definitely. You are absolutely correct. There are standard design principles that can be floated just like traditional coding. But what is the purpose of those design patterns? Those design patterns are tied to the design principles that Illya talked about throughout the presentation, the second half of the presentation. Those design patterns allow you to drive the acceleration of the application releases and to deploy independently these services much faster and independent of each other. The key word here is independent of each other. If you're deploying these services independent of each other and you're testing them independent of each other, you can do many more releases than you did previously. And if you're doing many more releases previously, we hope that you're releasing many more features for the business. That's the goal of why these design patterns are in place to help facilitate that, right? Again, it goes back to what I said all throughout the presentation. Business agility is the driver for microservices, and these design patterns support the principles Illya talked about, and they help you deploy faster and do more application releases.
Thank you. Oh, by the way, we have one more question about business agility. How does microservices drive business agility?
That's great. I'll take that. I know that one very well. Microservices, and then depending on the type of team that you have, startup, enterprise, mid-size, can very easily be worked on small independent teams that can work really directly with business, because the goal of a microservice is everything is contained together. The code, the infrastructure, everything. And there's basically a standard in and a standard out of it, right? So you can have an entire team that basically take care of this microservice or a set of microservices. Now, that really goes hand in hand with the notion that's called agile methodologies. If you're not familiar, agile methodologies is a polynomous term that can accomplish many things in business, right? It's a way for business to work directly with IT to get their things done faster. Now, if you are not familiar with agile methodologies and you would like to learn more about it, now Svitla Systems is an expert of that. We have, not only do we have numerous certified developers, professionals like Illya, we can also provide, we have numerous PMs, BAs, and Scrum Masters that are certified in agile methodologies that can help align your business to IT and, in essence, microservices.
Thank you, Thibaut. That was a great answer. Okay, actually, we don't have more questions. I guess we are good.
I'll just say that if anybody has
Hey, Ilya, could you please check one more question in our chat?
I don't see it.
I see it here. Give me 1 second. Illya, you spoke about using AWS services. Could we use these services if we're already using tools like Bitbucket for Git repositories, Terraform, Azure DevOps for CI/CD pipelines?
Okay, good. Thank you for question. Well, definitely. Despite we are speaking about AWS services, where AWS provide developer tools, we have a lot of customers which use different, I said tools stacks. So some of them prefer to use Atlassian product like Jira, Confluence, Bitbucket, and obviously it's quite easy to integrate, for example, Bitbucket pipelines or Azure DevOps pipelines with AWS services. So all this, most of modern DevOps tools allows to deploy AWS resources. So in this case, we're still able to work with microservices architecture, create microservices application, deploy it to AWS using, say, third-party tools. The same about Terraform. It's actually it's stated that it's cloud agnostic application, and it's possible to create code which could be deployed to AWS. Even more, it's possible to be deployed to two clouds at the same time, but it's required some additional work. So AWS services, AWS provide a lot of services, but it could be easily integrated with external tools. And even more, for example, if your application use some, additional services, like, for example, Elasticsearch hosted by Elasticsearch, in this case, we also could either keep AWS resources integrated with this external service, or even more, to provide an option to migrate to managed services in AWS cloud that provide open source and compatible with Elasticsearch open source tool.
Okay, that's a great answer, Ilya. Thank you. I just want to say, like, in summary, thank you, Ilya, for the very good high-level overview of microservices. And I just want to say Svitla Systems is has many certified professionals like Ilya who can help you through this journey that you're going through. Obviously, we saw the poll results. Many of you think it's very important to migrate. Feel free to reach out to us wherever you are in your cloud journey. We would love to talk to you, find out what you're doing, and see how we can help.
Well, thank you everyone for joining this webinar. If there are no more questions, we can end it.
Thank you, attenders.
Thank you very much. Appreciate it.
Thank you.